Hello everybody and welcome back to a new video on this series. In the last video we did look at creating an aim input and also giving us a UI debugger to tell if we're aiming and seeing how it sets the strafing back when we're aiming and stuff like that. So I hope everybody's excited for this new episode or video, because what we are going to be doing now is actually setting up the camera styles so that it goes back and forth between like closeness of the character, being far away from the character, or doing a super close up when we're aiming. So we're gonna have a bunch of shifting of the camera and whatnot, having it offset in many different places, just so it looks like a AAA game style camera motion and everything like that, right? So hope you're ready for it, because it's going to be, I'm going to hope that this video is not over 30 minutes, but it more likely could be over 30 minutes because there is going to be a bunch of stuff that I have to explain as we go through it, and I will do my best to explain what is going on at every part, especially since how I have everything commented within this, just so that way, you know, I can help everybody understand like what's going on. So at this point, let's go ahead and get started in this video. So what we are going to do now, so we have our aim set up here, and what we are going to do is we are going to set a function, and this is what's going to control our camera angles. But just before we start that, we need to create a structure file or a structure blueprint, because we need a place where we store all relevant data that we will be managing for the camera. So basically, in a simple run through of what a structure is, it is basically a file. I'm pretty sure you've seen like enumerations and whatnot if you've ever dabbled in it in here, but it's kind of like enumerations where it holds different values. But the structure is a bit more complex because you can adjust it to have different types of variables or values. So for example, you know, if I'm trying to have a place with all sorts of speeds involved, like a walk speed, a run speed, a sprint speed, a crouch speed, you know, you would create a structure file to hold those speeds and, you know, call them vectors, and then you could set values that you want each vector to be at. Or say if you're doing something a little bit more advanced, like you're creating a gun, right? A gun actor or model, and you need a place to store all relevant information of the gun, and you would store in there. So, you know, in order to show you what I mean, let's go ahead and jump into it. So what I'm going to do is we're going to go to our third person and then blueprints folder, and I'm going to create a folder here called data, where we're going to store a lot of our data files in here that we're going to grab in and out of our character blueprint. So once you do that, go ahead and open it up, and we're going to click into the space, and we are going to go to blueprint structure. And in this one, we are going to call it just like they call it in the game animation sample project, which is S for structure, simple camera params. There we go. So we got that. So we've made our first real data value file that we will be breaking and remorphing with new values and stuff like that, or reforming. So let's go ahead and open it up so we can kind of get the gist of what it looks like, right? So right here it's blank. It kind of, you know, in both sides where we have default values and we have structure. So this is what I'm referring to, of where you can start setting all sorts of values, and what you want to place in the structure files is relevant data. So that's why I mentioned two different types of relevant data, where maybe you want a structure file that has a bunch of different speeds in it, or maybe you want, you know, specific parameters for guns. Like if all your guns are going to have the same data, I want to say like blueprint or outline, where you have like current ammo, max ammo, what the static mesh is going to be of the gun, you know, that's all relevant data because it matches a theme. So that's kind of what you want to think about with the structure file. I struggled with understanding structure files for, you know, a couple weeks now, and that's basically kind of what I dumbed it down to help me understand, is you want to use structure files for relevant stuff. So if, you know, like I said, speeds, that's all relevant. Gun stats, all relevant. So stuff like that to hold all in one place. So let's go ahead and get our data. So what we're going to do in here is we're going to set a few different camera parameters, right? And I'll show you where we get these. And there's one that we're not going to get anywhere, but I'm going to explain what it does. So what we're going to do is we're going to create 1, 2, 3, 4, 5. We're going to do 5 different variables. So there we go. For our first one, we are going to call it the spring arm length. So as you've seen in the third person character, if we go into our viewport, how we have the camera boom right here, or if you've ever created your character from scratch in the viewport and how it becomes a spring arm, this is what we're getting. And so we're getting the length, and you would find that right here, the target arm length. So this is what we are getting when we talk about the spring arm length. So you will see that there's a value here, a default value of 400. However, what they have in the parameter file for the game animation sample is 300. So I'm going to keep it similar to that, but basically that would be the 400 would typically be the value we put in there. So if you want to do that, you're more than welcome to, but please try to follow along just that way you can kind of understand what's going on. So in this instance, we are going to call it a float, and we'll do all the values in just a minute. We're just going to convert all these, get them down first and stuff like that, and convert them, and then we'll start marking down the values. So the next one would be socket offset. Now where we get this one, if we hop back into the third person camera, the camera boom, or the the spring arm, if you look into here, you will see socket offset, and we're going to grab the default values out of here. So I'm just showing you one by one where we're getting these. So, and because it has 3 points, it's a vector variable. So we're going to change that over to vector for our socket offset. Then the next one would be a translation lag speed. This one took me a bit to find. Real quick though, it's going to be a float, but this one did take me a bit to find when I was looking for it originally, because it's not in the spring arm. If I remember correctly, it's in the camera. So if we look for the lag speed, or maybe it was in the camera boom. Let me see, lag. Okay, my apologies. It was in the spring arm. I think it's the next one that's in the camera. So how we have right here the camera lag speed, that's basically the translation lag speed that we will be getting. So if we go back into the camera params, we're going to go here to the fourth one and get our field of view, our FOV, gamer language. So let's go ahead and change that to a float and go back into the third person so I can show you where we're getting that. This one is in the camera right here, field of view. So now let's make our way back into the params, and the last one is going to be transition speed. And now this one is not in the spring arm or the camera. This is an actual value that is not, it is relevant, but it's not within any of the stuff that we have attached to our third person character. This is what we will be using to do our camera styles, where we change like in and out of like the aim style, the close-up style, and the far style, right? So this is what we are creating basically ourselves and giving like a value of what we think is good, but we're going to follow along with the default values that we found I found in the Game Animation Studio. So for this one, we're also going to call that a float. So once you have all of these, we're going to hop back into the default values and change them accordingly. So like I said earlier, with the spring arm length, it would be 400 that we saw in the viewport. But I'm going to keep it 300 just to match what the Game Animation Sample Project had. The socket offset, we're going to keep at 0. I'm not trying to offset it to start. We want the default values here because we're going to be adjusting them in the function. So then next, like I showed you where the lag speed was, it's going to be 10. And then our field of view where I showed you, it's going to be 90. And then here's where we set our own value for it, and they had it at 5. So when we do this, you will see what this 5 does, but it's basically this, like, the speed at which the camera transitions, and it actually goes relatively fast. So you will see that here later in the video once we put everything together. So let's go ahead and save this, and we're going to hop back into our third person character and back into our event graph, and we are going to go ahead and create that function. So over in the left hand side, go ahead and hit plus, and we are going to create the update camera function. So once you've renamed it and you got everything in here, we're going to go ahead and we are going to create some local variables. So, or we're going to create one local variable, but not right now. So what we are going to do, because this, I believe, is set public for a reason. I haven't found it anywhere else except here, but I'm going to copy kind of how the Game Animation Studio, the sample did it. So we're in here, we are going to create 3 public variables. So go ahead and create your 3, and we are going to call all 3 of them cam style. They're all going to have that prefix, but we're going to have far, and then rename this one to cam style close. Close. And then cam style aim. And then what we're going to do is we're going to change them from the Boolean, and we're going to search for the simple camera params. So if you type in S simple, you should get the simple camera params, and we're going to change all of these over to the S simple camera params. Alright, and then once you do that, go ahead and compile and save. And real quick, before we truly get started in this, what I'm going to do is I'm going to put the far, close, and aim within the camera grouping, and then we're going to move the others to a components grouping just to kind of get it out of there and match kind of what the game animation sample has going on, so we kind of avoid confusion and whatnot. So, and I'm going to put it back up here. But there we go. So now we have our camera stuff here. So go ahead and we are going to drag out and get all 3 of these, and we are going to set them up like this. So what we are going to do is we are going to do a couple selection nodes. So basically we're going to check if we're aiming, right? So if we're not aiming, then, you know, we get the close or the far style, but if we are aiming, we get the aim. And then another select node with another Boolean will determine like our far style. So go ahead and click into here, and let's get to select nodes and match them as such. So what we want to do now, once you have the select nodes, is we're going to get the ones to aim and put it out here, and the ones to strafe and put it right here. So basically what we're going to be doing, like I mentioned earlier, is if we want to aim, if that is true, then we are going to get the cam style aim. If we don't, we want to get close, and then it gets passed into here. But then whichever one of these, if we want to strafe, we're going to get the camera style far, or in this case, not want to strafe. So this one's kind of weird because you'll see what happens when we connect them, and we're going to go through it. So if we connect the aim to this index and the strafe to this index, let's go ahead, and if we want to aim, we want the aiming cam style. If we don't want to aim and it's false, we want to get the close-up style. If once we return this value, then it's like if we want to strafe while wanting to aim, or if not wanting to aim here, then we'll pass in the close or the aim out of here. If neither of these and we don't want to strafe, then we're going to get the far cam style. So basically what happens is, because this, as you can see, is set to true by default in here, we're going to end up starting out with the close param. So when I click it into here or clip it into there, so if we want to aim, if it's true, we're going to pass that into here. If we're strafing true, then we're going to return the aim style. If we don't want to aim, but we want to strafe, we're going to get the close style. If we don't want to aim and we don't want to strafe, we're going to get the far style. So basically I'm going to give you a little preview of what the far style looks like. And it's pretty much this. This is what we're going to be considering the far style. The close is going to be a little bit closer, and the aim is going to be even closer. So I'm going to go ahead and copy paste my comments over here, just so that way y'all have something if you want to jot it down for what you're following along with, and also too, just, you know, for as note references for later. So there we go. Boom. So there we go. We got both the comments. Let me set them to group movement so we can move them around. All right. So now, once we got that, this is where kind of like the nitty-gritty comes into play, where I understand, like I mentioned in the last video, like I understand kind of what's going on, but I'm going to do my best to explain what I think is going on. So if there is a veteran that does end up watching my video, I'm, sorry if I butcher this. I really hope you can explain it gently in the comments regarding this section. But so basically what we're going to be doing here is, since we're returning a structure value, so when you actually look at the cam styles, see how we have all of our structure values in here. So as you can tell, we have all three of these set to the same default values that we placed in our struct. So this next part of what we're going to do is we're going to actually be tearing them apart and changing them up. So we're going to go here from the return node, and we're going to get a break simple simple camera params, and we are going to enlarge that. So what a break node does in this situation is we get the input values that were given from here. So basically all of these default values that were given in the far, close, and aim going to be passed into here, and then this is where we get the output. So basically we have 300 for the length, zeros for this offset, 10 for the lag, 90 for the FOV, and the 5 for transition speed. So now what we're going to do is we're going to adjust and make new params in this section. So we're going to create a new variable in this called camera distance multiplier. Make sure I spell that right. Yes. And we're going to call this a float, and we're going to put it within our camera grouping. So this we're going to compile and save, and we are going to change the multiplier to a 1. I'm not sure why we're doing it a 1, but my only guess is that we're trying to do kind of a 1-to-1 making of these when we remake them, and you're going to see what I kind of mean by that. So we're going to get our distance multiplier and drag it out, and then we are going to get 2 multiply nodes. So copy and paste, and we have 2 multiply nodes. So we're going to start with the arm length, and we are going to put it in here, and then we're going to grab our multiplier and put it into here. So basically we're multiplying 300 by 1, and then going to be remaking it into our make node when we make it. And then in here we're going to grab our socket offset, plug it into the first one, and then we're going to change this second pin into a float and put our multiplier into that. So the socket offset vector, all values are being multiplied by 1. Then after that, what we're going to do is our transition speed, we're going to drag through, and this is where, actually no, I'm sorry, I apologize. Our transition speed, we do at the field of view next. So the transition speed, we're going to get a select float node, and you're going to copy and you're going to paste that again because we need 2 select float nodes. So the lag speed is going to go into the A, and then our B value is going to be -1. And then I'm going to go through this in just a moment to give you kind of my thoughts on this. So, and we're going to grab our transition speed, put that into A, and then we're going to call this -1 as well. So now what we're going to do is we need a Boolean value. And what we're going to be doing is we're going to be creating a read-only Boolean value. It's not going to be a local variable, and it's not going to be a public variable. It's going to be a function variable. And the way you make that is you go into the beginning function node and you add an input. And here is where we will make a function called interpolate. Or not a function, a Boolean called interpolate. So what interpolate means in a math sense is, say you have a couple points on a graph. Like let's say you had a point right here and then a point right here, right? Interpolate is going to be the linear pathing or the connection between both data points, and it basically tries to fill in best guess, data points in between those 2 points, so it has a smooth linear connection between those 2 points. So in this context, interpolate, what we're trying to do with these select floats on both the transition speed and the lag speed is we want to interpolate or transition smoothly in between our starting camera offset point and then the new camera point, for example, when we aim or when we are close or when we are far away. So that's what interpolate's doing here. And we set it to a Boolean value because what we want to do is we want to pick A, which, the transition speed, I think we set it to 10. If it's false, then we want to set it back to where it was. So basically we're going to transition, with this speed and the translation speed and the transition speed, on the A when we have the Boolean checked. If false, then we revert back to normal value or the previous point. So what we're going to do is we're going to right click into the space and we're going to look for our interpolate value. So as you can see right here, we have the get interpolate variable. And as you can see, it looks vastly different from what the other variable would be. As you can see, there's more points on the board because basically we created a read-only variable. And so with this variable, we're going to plug it into the Boolean values here. So now we basically have our basic setup. So what we're going to do now is we are going to create a make s simple param node where we then make the new values into here. So go ahead and connect all the corresponding pins here. The field of view basically goes across, and then the transition lag speed here and the return here. So basically it looks just like that. So hopefully I've explained it good enough here. I'm hoping that if someone has a better way of putting it in a simple form, I would love to know about it, make it a lot simpler for me to understand kind of what's going on here. So with that being said, though, I am going to copy paste my comment box here just for anybody that wants to copy down what's going on in here. And move that back to group movement. So like I have it, we split the structure, the camera params, so we can make adjustments accordingly on every tick, because we're going to be plugging this into our update tick function, or our event. So, and then when we pass back the new updated params into the make node, then set those variables to target camera params variable. So which is what we're going to do now. So we are actually going to create a local variable. So we're going to, off of here, promote to local variable, and we are going to call it target camera params. I was like, I hope I spelled that correctly. I sure did. All right. And then we're going to set it up here, and we are going to connect this pin. Boom, just like that. And let's move it down just because I want to see some evenness. Yeah. All right, so now we got that. So now we got a good major portion out of the way, and, you know, set that part up. So there's nothing I can really show you at the moment with how it looks because we're not actually making major adjustments yet. What we'll be doing is with the stuff that we're about to do up right now is where we sort of make the adjustments, or at least I assume it makes the adjustments. So just to make sure for testing purposes, yeah, we don't have any aim yet. So now what we're going to do is basically we're going to create a bunch of set variables, or not a bunch of set variables. We're not creating those. We're going to be getting set variables and making constant updates too. So you're about to witness the finterp2 and the vinterp2 nodes, which kind of what I was explaining here with interpolate is similar to what the finterp and the vinterp do, which is the finterp is a float interpolate 2 and a vinterp 2 is a vector interpolate 2. So let's get started on our first one. So basically what we're going to do is first we are going to get our target camera params. So we're going to control and click and drag. And what we're going to do here is we're going to right click and we're going to split the structure pins. So now as you can see, we now have all our variables that we placed in the structure file in this set node that we're getting. And we're going to make adjustments here that are going to be constantly set here. And you're going to see how that's done. So what we're going to do first is we're going to be updating field of view when we transition to the different points. So let's grab our finterp2 right here, and we are going to pass in the field of view to our target because that's the target param that we want to hit. And then the transition speed is going to be our interp speed. So this is what I was trying to mention earlier, where when we do the interp speed, this is where we're going to like go smoothly towards our intended target offset. So what we also want to do is get our world delta seconds. So every world delta second that goes by, or the delta time, or yeah, like every tick, we are going, that's, you know, how we make the adjustments until we're at our target point. So once we do that, we are going to get our follow camera, drag it out here because field of view only exists within the follow camera, and we are trying to set the new field of view for our follow camera when we do our different aim styles. So we're going to drag off here and do set field of view, and wrong one. We want to do the green one. Set field of view. Yep, right here under camera settings, set field of view. Put it right there, and our return value is going to go into here where we connected. So we are whatever new updated values we get, we're going to form into here. And then what we're also going to do is we're going to take the output and drag it into current. So basically what will happen is if we want to go forward, we get our current, which at the time we haven't made adjustments, where so far it'd be 90, but say we're going to go up to 100 or something like that for a field of view, or if that's the default that you set, right? Well, this is your current, and then it gets the corresponding adjustments when we do the aiming and shift our cam style, and then update this so that we have the new field of view or revert back to our old field of view. So now that we got that, hopefully I explained it well enough. I apologize if I didn't, but hopefully I did. We're going to set that nice and lovely looking. Yep, cool. All right. So now what we're going to do is we're going to work on the next part. So basically what I'm going to do is, just to make this a bit quicker for y'all, we are going to copy this, or at least not with those reroute nodes. We're going to copy this. Let's see. We're going to do it 2 more times because we have a vector interp at the end. So we're going to do 1, 2. So now for the new part, what we're going to do is we're going to disconnect the field of view, and we're going to get target arm length and shift it to our target instead. So basically, all of these interp2s are going to be the different parts of the targets that we're trying to hit. So we just did field of view, so we're going to do update our target arm length now. So as we saw earlier, our camera boom is the one that holds our spring arm length. So we're going to drag off there and get our arm length, set arm length, yep, target arm length. Connect the return value into here, and then the output into our current. So that way we're constantly transitioning when we're aiming, not aiming, strafing, not strafing. And then make that look nice. So boom, there we go. Oop. Shift that out a little bit more. All right. And then let's move that back slightly. And now here into our new finterp node, we are going to be updating the lag speed. So our lag speed now needs to be the new target. And then we get our camera boom and look for the lag speed, the camera lag speed that I showed earlier. So set camera lag. Yeah, right here, set camera lag speed. And then again, we're going to get the output node, connect it into there, and then the output node here and connect it to the input here. So that way we're constantly, we update our camera, our lag speed. I had to think about it for a minute, getting tired. And then we are going to move this back, and now what we're going to do is we're going to grab these two and we're going to copy paste them over here, because now we're going to work on the socket offset now. So for this one, we want to get the vinterp2, and our target is the socket offset, our delta time here, and our transition speed to the interp speed. And then the offset is going to be on the camera boom. So we get our camera boom and get the set socket offset node here. Get the output and put into here, and our output here and put it into the input here. And then make it look nice. All right, perfect. So now, as you can see, we have 4 major sections that we are updating. So all of them consist of the transition speed, because that's basically the back and forth between the point A and the point B of where our stuff is located. So, like I showed earlier, where we're going to have a default value of, the target arm length of 300, but then when we update it to maybe like 500 or 200 when we're aiming, stuff like that, right? So that's pretty much what's going on here. Like, all these are going to be made as we update our camera and stuff like that accordingly to what we've plugged in. So go ahead and connect all these nodes together now. Oop, come on. Connect that here, connect that here, move that down slightly. Oop, can't believe I missed that. All right, and then move that down. Move this down and over. And what I'm also going to do is I'm going to copy my notes that I have over here for y'all to jot down in case y'all want to copy those as well. All right. So basically that is, in case you want to pause the video and write that down. And then let me grab the other ones. And hopefully my comments make sense when as y'all see them. Basically they're repeats the whole time, but to me it kind of makes sense. So okay, group, and then final one. Alright, perfect. Now we got all the stuff laid out. Cool. Let me move that up to match. Yeah. And there we go. So now we got all of our stuff done. So now we are ready to witness basically what is going on. So now let's go ahead and compile and save. So just to go back over it, we are setting our cam styles here, or selecting our cam styles depending on if we're aiming or if we're strafing. And then we are setting up our values accordingly, or remaking our values based off of the multiplier that we want, and interpolating between our A and B points. So what we're going to do now is we do have to do one final thing. I don't believe I have a return node. No, I don't. So go ahead and go back into the event graph and then scroll up to the top, and we need to be on the event tick. So what we're going to be doing here is we need to add our camera function in two places. The first one being the event possessed. So what I'm actually going to do is I'm going to move this down, move our event possessed up, move our event tick down. And basically we're going to get our update camera function, put it here, and connect our node. So as we made earlier, we made an interpolate Boolean variable. When we possess our character, we want to make sure this is false, so we start at the default values. When we do we want to get it again and put it on the event tick and connect it, but then this time set it to true, because as we're playing, we want to constantly update our camera values. That way the aimings are appropriate. So now let's go ahead and compile and save, and let's go ahead and try it out. Let's see. What did I miss? I know I missed something now that I think about it. Believe we got our aiming. What did I set up? Camera, we got the boom. My apologies, guys. I gotta double check what I did here, because I basically copied what I was doing from my project, but it looks like I may have missed something, and I'm trying to think of what I missed. Okay, guys, I'm back. I figured out what I did wrong, and I apologize for this. So what we should have done, or what I should have gotten y'all to do, so we are correct in setting them up, but what we needed to do was set up appropriate values here within our variables. So for example, I completely forgot about this. I forgot I even made that adjustment. So if y'all do have a comment bubble, I would suggest writing that down in the comment bubble so you don't forget. But basically we create our new styles in here. So we have the default stuff that we revert back to, but when we do, for example, aiming, we want to set this spring arm length to 200. And then, and I'm going through the default values that was set in the game animation sample for these modifiers. So we're going to get 50 here for the Y of the socket offset, and a 30 here for the Z offset. The translation lag speed is a 15. The field of view is going to be 80, and we're going to keep the transition speed there. So now if we go to close, and let me shift it over here, they have it at 225, and then a socket offset of 45 on the Y, 20 for the Z, and they kept the lag speed and the FOV and the speed the same way. And then the far style, they kept the default values, although the far style has a Z offset of 20. Actually, they also changed this, and the lag speed to 6, and then the transition speed to 2. So this is what I confused y'all on. I apologize. So now what's going to happen is whatever values that we have set in the aim, if we're aiming, it's going to pass through this, and if strafing is true, then we're going to pass into here, and then we're going to remake it accordingly. So we're going to interpolate those values. So like I showed you earlier, where when we look at our values, how it was set to 300, yeah, like right here, 300, zeros, 10, 90, 5. Basically now if we were aiming, it's going to update this to have the aim parameters that we set, or the values that we set. Or if we're trying to not aim and we're just close by strafing, we're just doing this. And then if we're not strafing or not aiming, we're doing the far one. So that's how it updates in here, where it gets those values, those newly put values in here, and sends them to update the field of view, the target arm length. And then that's how we made them into here. And then when we come back, then it's going to re-update them with the default values that we had. So now you'll be able to see the difference. So if we hit play, you should see something already new. So our character is close up, they're ready for battle, they're ready to get it. So now if we are aiming, as you can see, we are now going back and forth with the socket offset. So that's pretty cool, right? So now if we're aiming, jumping, look at that. So see, we're getting different cameras. And if we do the far one, so if we click the middle mouse button to orientate, we are now far away, kind of close to the default settings that we had for our character before doing this. So look at that. That's pretty cool, right? Makes me giddy when I see that. So that's pretty much it. We have now created a full-on aiming system, and it only took 2 parts. So I'm hoping that I didn't drag the video out too long, but I knew this one was going to be a pretty long video just because of the stuff that I had to cover in this one. So I hope you really enjoyed this. I hoped it kind of opened your eyes, and hopefully I explained it a little bit more on how to set up a functional aim and camera offset so it looks like AAA game style aiming system, camera system, etc. And if you even want to, you can even go into these and set up styles that you prefer. So if you truly wanted to, you can create as many select nodes and cam style nodes that you want, or variables that you want, and just like, hey, if I want to strafe, or if I want to do a run, I want this camera angle. If I am walking, I want this camera angle, etc., etc. Or if I'm battling, fighting somebody with swords, shooting somebody, I want these camera angles. So I think it's really cool. So hopefully this has been knowledgeable for you. So now if you ever do decide to go into a game animation sample to just mess around with the aiming system that they got, especially when you're utilizing your guns, this is where you're going to be making the adjustments. So been cool. It's really cool. I love it. So basically that is going to be it for the aiming. So we got all that stuff done. So now the next videos that we will be covering they're gonna be pretty long, but they're gonna involve adding our crouching button. We're gonna make a walking button, a sprinting button. We're gonna make the input actions for those. And then what we're really going to touch on after we get those inputs set up, and I'm going to go through making a video at a time for each of those inputs. So it's going to be multiple parts because just of how I'm going to have to bring it out. But when we actually do the final thing of this, so once we get all the input actions, the next step that we will be making, and let me bring my other project over, is we will be creating this update movement function. And as you can see, it already looks weird, right? Because it's like, hey, what's desired gate? Hey, what's calculate max speed? Well, these are going to be pure functions that we talk about and how to make those, as well as setting up an enumeration data file, looking at basically kind of what goes into this system. I got that all planned out. And then the calculate max speed. This looks scary, but I promise you it's actually really cool and really easy to understand, or hopefully I can explain it in a way that's easy to understand. But we're gonna go through those, and I'll give you a demonstration just basically on how it looks. So as you can see, we're moving, we're running around, but then if we walk, we got certain speeds. If we're aiming, we have certain speeds. If we're crouching, we have certain speeds, stuff like that. And also too, if you see the UI debugger, you can see that I have a run gate and a sprint gate, a walk gate. I don't have crouching, but that's part of my stance. So we'll be going over all that stuff, which I think is really cool, but I have to break it up into multiple parts. So hopefully this has been enjoyable, guys. Hopefully I get to see y'all in the next video where we go over just making the inputs and whatnot. So other than that, if you enjoyed, please join my next video. And so other than that, you guys take care. Bye.